at xi and tj. Okay. Which of them could explain the exercise related to this formula? This example. This is the example for above page. This is an example for symmetric finite difference for second derivatives. No, not this. Central finite difference. Central finite difference. This is respect t and then respect x and t. In central finite difference, we have ux at the ux I and j is approximate by ui plus 1 and j minus ui minus 1 and j over 2 delta x. Okay? Means we should use before and the next point for approximate the ux at I and j. This point have the indexes I and j. The next point at this row, we have the indexes I plus 1 and j. And the previous point at this row, we have the indexes I minus 1 and j. Okay? And for central, we use ui plus 1 and j minus ui minus 1 and j over 2 delta x. This is the formula for central finite difference respect x. Which of them could explain this part? In Arabic, not in English. In Arabic, no problem. Which of them could you explain this exercise in Arabic for each for another students? Miss Sima, can you explain this exercise for other students? In Arabic, you can start. This is the formula, and the U for this formula is this. U is x2 plus t2. X start from 0 to 1. T start from 0 to 1. Delta x equal 0.25 and delta t equal 0.5. Okay? And and we have grid at this page. This is my grid, my mesh. And at this mesh, we compute the U at each point of the grid. We have U, and we can, and we want to compute U respect X with central finite difference for each point at this page. Okay? Please start your explain.
سيما يعني اشرحي لها المثال. سيما اشرحي لها المثال الموجود. طبق عليه.
Miss Sima, please start. No problem. You can speak in Arabic.
مضاعف 6 س ما قلها، يعني نقطة نضاعفها بنقطة ثانية، نطرح معتها النقطة الثانية مضاعف.
لا مو مضاعفة، قبلها. ليش انت استقبالك شنو اكو؟ اقول لك يو للواحد والصفر، صح؟ اي اوكي. هو انت هذا القانون مالته غير هذا القانون مالته؟ اي عادي. هي بصورة عامة هي على ما قبلها، بما أنا ما قبلها بالسالب طلع هنا صفر، طلع ليش بالسالب ما موجودة. شوف أنت هنا شنو عندك لي فوق بالبسط؟ يو للآي زائد 1 للجي، مو صحيح؟ يعني المشتقة الآي زائد 1 واللي وراها يعني الجي ثابت. والثاني المشتقة آي ناقص 1، يعني الأقل من عندها بشقد؟ خلاص هو نفس الشيء قلت لك.
خانم طالب
لا
اگر
هو
مشکلی هست
سيما هو هي بس هي اصلا هي مطيتنا الفترات بالسؤال الاصلي، يعني مو الجي يساوي 1 2 3 بالسالب اصلا بقى.
Everybody, please listen to me. My goal is this discussion with another. It's very good. It's very important and very useful that you are discussing with each other. If you have any problem, please let to me your problem. Okay, continue. خانم زینب بهشون بگه که این خیلی خوبه که شما با هم دیگه رو مسئله بحث میکنید، خیلی مفید، یعنی این خیلی به یادگیری شما در کلاس کمک میکنه. اگر ما کلاسمون حضوری بود من حتما از شما میخواستم که بیاین و این قسمت ها رو ارائه بدین، یعنی بحث کردن شما با هم دیگه خیلی به یادگیریتون کمک میکنه. هدف من اینه که شما با هم دیگه بحث کنید که بحث رو بهتر متوجه بشید. اگر در حین بحث مشکلی هست یا سوالی هست که از خطش بر نمیاد بگین که من توضیح بدم براتون. اینو لطفا بهشون بگین.
باشه. هي تقول أنا فكرتي بالموضوع مالتنا بين أنت وواحد يتناقش ويا الثاني وتعرفون، يعني حتى لو مثلا فرضا من عندي ما فهمتوا أي شيء فهمتوا وحدة تفهم الثانية أبسط ما يمكن فتوصلون النتيجة، وإذا كنتم ما وصلتوا النتيجة اسألوني إليه. هذا مفتهمين. أكو أحد ما مفتهم؟ وهي تقول أكو أحد ما مفتهم قولوا لي.
زينب بس ليش زينب ليش ضعفت هنا؟ أنا أخذت صار مضاعف هنا أنا عندنا.
وين المضاعف؟ هذا قانون غير؟
عد من واحد هسه 2 دلتا اكس صار مضاعف هنا أنا عندي.
هو غير
قانون يعني هذا؟
قانون هذا. لا اتوقع، لا ما اتوقع هيك. يعني بين اي وجي من هاي الجهه
قصدي شلون صار مضاعف
ومن هاي
هنا
الجهه؟
لان اعتقد بالمثال بالمحاضره السابقه ما عندنا مضاعف.
لا شوفي يمكن هنا من هاي
فعلا صحيح.
تعتبر من جهه اليمين دلتا اكس ومن جهه اليسار هم دلتا اكس ودلتا اكس يصيرن 2. ايه بهذا الرسم اللي هنا ايه صح.
اي هو اي صحيح صحيح، لان دلتا اكس بدلتا اكس صار
خان باقري
2 دلتا اكس، وسيليها على هذا زين خلينا نتاكد من عده.
ايه خان باقري میپرسن سر فرمولی که هستن اینجا تو مخرج 2 دلتا اکس.
بله
من بهشون گفتم چون این و طرف راست یه دلتا اکس داریم، طرف چپ هم یه دلتا اکس داریم، این شد 2 دلتا اکس. میگن چرا دو تا این قانونه که
این فرمولشه، ولی ما جلسه قبل براتون حلش رو گفتم، حلش اینجاست. This is the solution.
قانون هذا شفتوا؟
The solution when we write the Taylor theorem for delta x and also write the Taylor theorem for minus delta x by subtracting the first expression and the second expression. We have ux is equal ux x0 plus delta x and t minus u at x0 minus delta x and t over 2 delta x. 2 delta x is obtained from subtracting a second expression, this expression, from the first expression. When we subtracting these two expression, we have the 2 delta x in the فرمولا. اوکی؟ این در واقع وقتی ما قضیه تیلور رو با دلتا ایکس می نویسیم، بعد با منفی دلتا ایکس می نویسیم، اینها رو از هم دیگه کم می کنیم، این 2 دلتا ایکس اینجا ظاهر میشه. به خاطر اینه 2 دلتا ایکس از تفریق اینها حاصل میشه. Why we subtract these two expressions from each other, we obtain 2 delta x in our formula. Okay, and when we write this formula for each point, for example xi and tj, we have ux at xi and tj is approximated by ui plus 1 and j minus ui minus 1 and j over 2 delta x. It is the formula, no optional, it's formula, and we should use 2 delta x for central final difference. Okay?
Okay.
Continue.
خان باقری
بله.
میگن اگه مثلا سوال اومد تو امتحان برامون مثلا مثال میدین یا مثلا باید مثلا مشتق کنیم؟
نگاه کنید اینا رو فعلا مقدمات، ما میخوایم با این حال امروز میبینید که میخوایم با اینها معادله حل کنیم. خب اینا فقط ما داریم یاد میگیریم که اینها چی هستن، بعد اینها سرهمبندی میشن تو معادلات PDE. تو PDE ها میخوایم مشتقات جایگذاری کنیم، بعد معادله حل کنیم، میخوایم جواب معادله به دست بیاریم. ولی اینکه از چه تقریبی استفاده کنیم، حالا فوروارد باشه، بکوارد باشه، سنترال باشه، اینو تو مسئله براتون مشخص میکنم.
بله. تقول هذني بالنسبة هذني كل المقدمات بالنسبة راح ناخذ لنا معادلات ونستخدم هذني القوانين الباكورد والفوروارد والسنتر بالمعادلات اللي راح تجانا أحدد لكم إياهن. يعني أتوقع هذني اللي أخذناهن كلهن مقبلات بالنسبة للموضوع اللي راح يجي. إيه.
Okay. If you have any question, let me know. And if you have not any question, I want to continue. If you do you have any question? Do you have any problem?
No.
At this session, we are trying to obtain the formula for the second derivative of u, part 3D. If we write the Taylor's theorem for u at x0 plus delta x and t, we have ux0 and t plus delta x, ux at x0 and t plus delta x2 over 2 factorial, uxx at x0 and t plus delta x3 over 3 factorial, uxxx means the third derivative of u respect x at x0 and t plus o of delta x4. We write the Taylor theorem for order of 4, order of delta x power 4. And then we write the Taylor theorem this time by using minus delta x, okay? The first expression, we use delta x for Taylor's theorem, and this time we use minus delta x in Taylor's theorem, and we have ux0 minus delta x and t equal ux0 and t. This time we have minus delta x ux x0 and t plus delta x2 over 2 factorial uxx x0 and t minus delta x3 over 3 factorial uxxx at x0 and t plus o of delta x4. At the first expression in the first line, we have ux0 and t, and in the second line, we have also ux0 and t. In the first line, we have plus delta x ux, but in the second line, we have minus delta x u respect x. In the first line, we have plus delta x2 over delta x2 over 2 factorial uxx, and also in the second line, we have plus delta x2 over 2 factorial uxx. In the first line, we have plus delta x3 over 3 factorial uxxx, but in the second line, we have minus delta x3 over 3 factorial uxxx, and for both of them, we have plus o delta x4. Okay. This time, we are trying to add these two expressions with each other. We are trying to add first line to second line. We want to add these two expressions with each other, and we have at the left hand side we have ux0 plus delta x plus ux0 minus delta x and t. When we at the left side we have u at x0 plus delta x and t plus u at x0 minus delta x and t. And for right side, when we add the right side of the first line and the second line, we have ux0 plus ux0, and we have 2u at x0 and t. The next term, at the first line, we have plus delta x ux. At the second line, we have minus delta x ux. When we add these two terms are simplified with each other.
خانم باقی اگه بخوایم این خب این حذف شد مشتق اول مشتق دوم اگه بخوایم جمعش کنیم چقدر میشه؟
الان همین دیگه داریم به دستش میاریم. ما میخوایم
این
مشتق
چقدر
اول حذف بشه که ما یه فرمول برای مشتق دوم به دست بیاریم. هدفمون اینه.
خب منم همینو میگم، ولی خب بخوایم جمع کنیم میشه
نه دیگه این دو تا جمع با هم ساده نمیشه.
جمع کنیم، بذار جمع کنیم. میشه 1 و 1 2 و 2 فاکتوریال چند میشه؟ با 2 فاکتوریال
میشه 2 1 دوم به اضافه 1 دوم میشه 1. بذار من ادامه بدم، بذار بحثم ادامه بدم.
باشه.
حالا آخر برم ببینیم متوجه میشیم. ux and minus ux are simplified with each other. The next term is plus delta x2 uxx, and also we have plus delta x2 over 2 factorial uxx. When we add these two terms with each other, we have delta x2 uxx at x0 and t. 2 factorial and 2 factorial means 1 over 2 plus 1 over 2, and the result is 1. And we have delta x2 uxx at x0 and t. When we add the last term with each other, delta x3 over 3 factorial in the first line, and the second line we have minus delta x3 over 3 factorial uxxx. These two terms are simplified with each other. And for the truncating error, we have O of delta x 4 is remain for us. Okay? At this compute, the ux is simplified, and in the result we have not the u respect x, but we have uxx. This part at this line we have not ux, we have uxx. When we obtain uxx from this formula, we have ux0 plus delta x and t. 2ux0 and t move from right to left, and we have minus 2ux0 and t, and then plus ux0 minus delta x and t, and over delta x2 and delta O of delta x4 over delta x2. This equal to uxx at x0 and t. Delta x4 and delta x2 are simplified with each other, and we have the formula, the order of truncating error, O of delta x2. Okay? The result formula is uxx at each point such as xi and tj, uxi plus delta x and tj, minus 2u at xi and tj, plus uxi minus delta x and tj over delta x2, minus O of delta x, or plus O of delta x2. By dropping the order of truncating error, we have uxx at xi and tj is approximate ui plus 1 and j minus 2ui and j plus ui minus 1 and j over delta x2. This is the second order symmetric finite difference approximation for uxx, not ux, uxx. And this is the second order because we drop the O of delta x2. And this formula is the second order symmetric finite difference approximation to uxx at xi and tj. Please let me if you understand this part. If you have any problem, if you have any question, you can ask. Is it okay? خانم زینب مشکلتون حل شد؟ میس زینب solve your problem.
الان براتون میفرستم رو واتساپ بگین چرا. منظورم بفهم.
باش. Please study and if you have any question, let me know. Until now, we introduced for you three formula for first order approximation: forward, first order, forward and backward, and central. This formula is used to ux, the first derivative of u respect x, or first derivative of u respect t. But this formula is used for the second derivative of u respect x or respect t. This formula is used for uxx or utt, and the order of error is delta x2. Please attention to me. For this formula, we use 3 points. This formula is a 3-point formula. Formula 3 نقطه‌ای هست. I minus 1 and j on I and j and I plus 1 and j. The coefficient for u at I minus 1 and j is 1. The coefficient of u at I and j is minus 2. And the coefficient of u at I plus 1 and j is 1. Please see this formula. U I plus 1 and j, the coefficient is 1, minus 2 u I j, and finally u I minus 1 and j with the coefficient 1 over delta x 2. The power of delta x for second order approximation to uxx is 2, not 1. Please be careful. I'm checking the problem of Miss Zainab. Miss Zainab, please attention to me. At this stage, when we add these two terms with each other, we have delta x2, okay, over 2 plus delta x2 over 2, okay, and the sum of them is delta x2, okay? 1 over 2 plus 1 over 2 is equal to 1. And then this term is multiplied to uxx. یعنی خانم طالب دلتا x دو دوم به اضافه دلتا x دو دوم مخرج مشترک که بگیریم دو دوم که مساوی با 1 میشه. به این خاطر دیگه ضریب 1 دوم ما نداریم، ضریب 1 میشه. اوکی؟ Is it clear؟ براتون حل شد مشکلتون؟
بله بله بله.
بسیار. Is it clear for all of you? Is it clear for all of you? Okay. At this file, the example for derivative, at this page, we are going to solve uxx at each point of the grid by using symmetric finite difference for second derivatives. Okay, as it said, we have uxx and I and j equal to u I plus 1 and j minus 2 u I and j plus u I minus 1 and j over delta x 2. Okay. We start from the first row. At the first row, we have t set t0 equal to 0. Okay. And we have x0, and then we have x1, and then we have x2, and then we have x3, and finally we have x4. Okay, we are going to compute uxx at the first point of this line, of this row. At the first row, with the indexes for t is 0, we are trying to compute uxx and t0. When we are using symmetric finite difference, we should use 3 points. The previous point, at the same point, at the next point. For x0, we have not the previous point because the x0 is the first point. At the end, the previous point, there isn't. Based on this formula, we have u1 and 0 minus 2 u0 and 0 plus u minus and v0. And we haven't u at minus 1 and 0. And also, and then we cannot compute uxx for the first point at the first line. Okay? We go to the next point, and we must compute uxx 1 and 0. Based on this formula, we have 1 and 0. You should write u2 and 0 minus 2 u1 and 0 plus u0 and 0 over delta x2. Okay, u2 and 0, u1 and 0, and u0 and 0, we have the value of u at this 3 point. When we replace this value for this formula, we have 0.25 minus 2 at 0.0625 plus 0 over delta x2. Delta x is 0.25, and then delta x2 is 0.25 power 2, and the result is 0.0625. When we compute this fraction, the result for uxx at x1 and t0 equal to 2. Okay? For the next point, means uxx 2 and 0. 2 and 0 means uxx at x2 and also t0. Means we are still in the first line. We are still in the first line. In the first line, the t is constant, and we have t0 equal to 0. x0, x1, and now we are computing to uxx and at x2. In x2, the next point is x3, and the previous point is x1. and we should use u at this point and also u at this point and also u at this point. For u at this point, we should use the coefficient 1. For u at x2 and t0, you should use the coefficient -2, and for the next point, we should use the coefficient 1. You can see these details at this line. U 3 and 0 minus 2 u2 and 0 plus u1 and 0 over delta x2. And when we replace this value of u for them, we have 0.5652 minus 2, 0.25 plus 0.625 over 0.0625, and when we compute this fraction, the result is equal to 2. And for the next point of this grid, or this mesh, we can compute the uxx similar this way. Please compute uxx for the second line, for the second row, and send to me your solution. Please compute uxx for the second row and send to me your solution. خانم زینب طالب به دانش اعلام فرمود که بیان مشتق مرتبه دوم رو با همین فرمول سیمتریک برای سطر دوم حساب کنن همین الان و حلاشون رو در واتساپ برام بفرستن. سطر دوم میشه uxx
المشتقة الثانية بالنسبة حسب هذا القانون
T1 x0 x2 x1 x2 x3 and x4. For all of this point, please compute uxx by this formula by using symmetric finite difference and send to me your solution.
هسه تحلوه هسه تدزوا لي اياه. دزوا لنا القانون سيما. يعني ما موجودة ذاك المحاضرة، ما أعرف القانون. لا مو قانون، هي بدايتها القانون الرئيسي اللي بالبداية الإكسات والوايات والدلتا إكسات. هذا اللي نربع هي هاي الدال اي.
I'm waiting for your solution in WhatsApp. Compute UXX for the second line. The second line means T1 and X0, X1, X2, X3, and X4. Please, all of them solve this UXX. It's okay. UXX 0 and 1. This your activity is for a class grade or a class score. If you send me your solution after we start solve the problem, I cannot consider this activity for a class grade. وقتی من شروع به حل کردم اگه برام حلی ارسال کنه دیگه نمیتونم به عنوان فعالیت کلاسی برای شما در نظر بگیرم. تا قبل از اینکه شروع کنم به حل شما بایستی حلاتون برام بفرستید.
داریم حل میکنیم خانم باقره.
اینو کلی گفتم. کاری به الان ندارم
بله.
کلی. It's in general.
دكتورة.
بفرمایید.
Okay, doctor. Sorry, doctor. I can ask you.
Yes, of course.
Doctor, I send you on WhatsApp for research with you. Yes. I'm course 2. I'm going to university and talk with the Dr. Hadi Hoshman, and he say me if you need any doctor, you supervisor for you, you can research with you if the doctor is agree for you. Yes, doctor.
Yes, I can be your supervisor for thesis, but you should stay sometimes. At this time, I'm very busy because of our class, and from next week, I'm free, and I can talk to you for your thesis.
Okay, doctor. Doctor, you what respectively of doctor? Respectively for doctora.
Please repeat.
What respectively in Persian رشته in numerically or differential equation?
Your question is about my field.
Yes.
My field is numerical analysis and partial differential equation, fractional differential equation, ordinary differential equation, and programming with MATLAB, Python, and my interesting field is numerical solutions for equations, ODE, PDE, integral equations, and also analysis of these equations such as stability, convergence, and so on.
Yes, doctor. Good. Doctor, if you can working in fraction differential equation.
Fractional, yes.
Yes,
Fractional.
good, doctor. I need the research for this.
Okay. If you want to study the fractional equation, you should first study the ODE and then go to the fractional or the ODE.
Yes, doctor. I study ODE, but fractional I don't have. Yes, I study.
Theoretical ODE. Theoretical ODE.
No, doctor. Yes. Doctor, I have a little information about your fraction. But fraction in dynamical system, it is good research.
Yes. Your interesting is the theoretical or numerical solution for fraction equation.
No.
Theoretical or numerical?
No, theoretical.
Theoretical?
Yes, no problem. If I study for numerical, no problem. You say me you need research for numerical or theoretical? Yes.
Yes. Today, numerical is very useful. Is very important.
Yes.
Numerical inside the, in fact, theoretical, both of them is very important. Okay, the next week I'm going to talk with you about your proposal.
Okay, doctor, thank you, and I thank you very much for present for lecture, and you listen for me.
Okay, you're welcome.
Okay, doctor, thank you.
I hope you be a success.
Okay, doctor. Good luck and Khuda Hafiz.
Goodbye and have a nice time.
Okay, thank you, doctor.
The students, where are you? Do you solve this problem? Miss Zainab, Mr. Hassan Isa, Miss Sima, where are you? حل کردین بفرستید. Please send it via WhatsApp.
اون 2 تا نقطه دیگه 2 تا مشتقش مونده. 3 تا رو در آوردیم 2 تا دیگه مونده.
أيوة.
يا عزيزي أنا ما عندي سنين ميلك. أنا بدي أطلع ناتج نهائي بس أطلع قيم مالتهن ما لحق. ها لازم كل زين والسالب يطلع ليش هملتي أول وحدة أول وحدة هاي هنا -1 و1 هي لازم يطلع لي عشان كل أول وحدة يمكن أتوقع كل أول وحدة وآخر وحدة يطلع لي يهمل. إيه مو أقول لك يهمل أول وحدة وآخر وحدة يعني بعد اللي شقيت كم وحدة طلعتي؟ صفر 1 إيه يهمل إيه
Miss Sima, I'm checking your solution. The first line, you write uxx 0 and 1, u1 and 1 minus 2, u0 and 1 plus u minus 1 and 1, not 0 and minus 1. The second index, the second subscript is constant and is 1 because we are at the second row, and in the second row the index of t is constant and is 1. You should write u1 and 1 minus 2 u0 and 1 plus u minus 1 and 1, not u0 and minus 1. Do you understand? Yes? Miss Sima, can you hear me? Are you understand your mistake? Please see your solution. uxx 0 and 1, okay? You write u11 minus 2, u0 and 1 plus u0 and minus 1, okay? The third term, you write u0 and minus 1. It's mistake, it's incorrect. You should write u minus 1 and 1, okay? Minus and 1, not 0 and minus 1. The second index for all of them should be 1, 1, 1. U 1 and 1, 0 and 1, and minus 1 and 1. Okay? 1. The second is okay, and you reply, place. The third line is okay, and the fourth line also is okay. And what about uxx 4 and 1, Miss Sima? Uxx 4 and 1. Miss Naim, I'm checking your solution. The first is okay. Miss Zainab, you write uxx at 0 and 1. 0 and 1 should be indexes. Okay? Miss Zainab, can you hear me?
Yes.
خانم زینب نگاه کنید UXX نباید پرانتز بذاریم بنویسیم UXX پرانتز 0 و 1. این 0 و 1 باید اندیس باشه، نباید اندیس پایین باشه. دور UXX پرانتز بذارید، اندیس پایین 0 و 1 بذارید، یا اندیس پایین 1 و 1 بذارید. اینا در واقع الان اون UXX 2 and 1 تون 2 و 1 تون درسته، ولی باید دور UXX پرانتز بذارید. اینا رو اصلاح کنید که نوشتارتون اصلاح بشه. بسیار
باشه.
دومی درسته، او یکتونم درست، تو وانتونم درسته. پلیز خانم زینب U3 and 1 and 4 and 1 رو هم حساب کنید.
بله دارم حساب میکنم خانم آقای. چطور طلع صحیح؟
Miss Sima, the last line for you is okay, and I put the positive grade for you. Yes, I put the positive grade for you. برای شما نمره مثبت گذاشتم. چون سر کلاس فعالیت داشتیم و حل کردیم، براتون نمره مثبت کلاسی گذاشتم، هم برای شما هم برای خانم طالب، زینب طالب. برای جفتتون نمره کلاسی مثبت در نظر گرفتم. مثل عدنان سلمان و مستر حسن ایسا، پلیز بی دی کلاس، در کلاس باشین، با کلاس همراه باشین. Okay, Anka, I continue. Please don't send to me any solution, because I start to explain the solution of the UXX for the second line. For the second line, in the second line, we have again 4 points. First point, X, for the first point, the value of U is indicated by U0 and 1. Because why I write 1? Because we are in the second row, and for second row we have T1 is equal to 0.1. The first point, the U is U0 and 1. For the next point, we have U1 and 1. For the next point, we have U2 and 1. If you be careful, you see that the second subscript is 1. For all points, the second indexes is 1. 0 and 1, 1 and 1, 2 and 1. The next point is U3 and 1. And finally, for the last point, we have U4 and 1. Okay? For UXX, 0 and 1, we should use the next point, the same point, and the previous point. For the first point at this line, we have not the previous point, because we have not the U at U with the indexes -1 and 1. And so we cannot compute UXX 0 and 1 by using symmetric finite difference. For the next point, U1 and 1, we should use U2 and 1 by coefficient 1. We should use U1 and 1 with the coefficient -2, and also we should use u0 and 1 with coefficient 1. Means 1 u2 1 minus 2 u1 and 1 plus u0 and 1. u2 and 1 minus 2 u1 and 1 plus u0 and 1 over delta x2. By replacing the value of u at this point, finally, we obtain that this derivative is equal to 2. For the next point, means the third point at this line with the indexes 2 and 1, we should use the next point, means u at 3 and 1, also u2 and 1, and also u1 and 1. The coefficient for u1 and 1 is 1. The coefficient for u2 and 1 is -2, and the coefficient for u at 3 and 1 is 1. And we have this formula: u3 and 1 minus 2 u2 and 1 and plus u1 and 1 over delta x2. And by replacing the value of this u, finally we have the result is equal to 2. And for the other point, the similar way is used for computing the uxx for the next line under each other. The next part, we are going to use the symmetric finite difference for second derivative. This time respect to t, ut, I, and j with the symmetric. This is u. Is utt. I should write utt, not t. It is incorrect, and t is dropping as a mistake. Utt ij is equal ui j plus 1 minus 2 uij plus ui and j minus 1. This derivative is the second derivative of u respect t. For the second derivative of u respect t, by using the symmetric finite difference, we should use 3 points. Our point itself is u, I, and j. The previous point is in the previous line, and with the previous line, I is constant, and j change to j minus 1. And for the next point is in the next line, next row, and in the next row also I is constant, but j comes to j plus 1. We use the 3 points for each point, such as p, I, and j, for approximate utt at I and j. You should write ui j plus 1 with the coefficient 1 minus 2 ui and j. The minus 2 is coefficient for uij. The coefficient for uij is minus 2. And the coefficient for I and j minus 1 is also is 1. Means we have 1 ui and j plus 1 minus 2 uij plus 1 or plus ui and j minus 1. Then this value of u is over of delta t2. We are trying to compute UTT for each of the point of a grid. For the first point, if we want to compute UTT for the point at the first line, we have u 0 and 0, then we have u 1 and 0. Because we are in the first line, the second indexes is 0 for all points in the first line. The next point is u2 and 0. The next point is u4, 3 and 0. And for the last point, we have u4 and 0. Okay? We want to compute UTT at this point. I should use the previous point and the next point. We have not the previous point in the first line because before the first line we have not any u, we have not any line, and not only for u0 and 0 but also for u1 and 0 and u2 and 0, u3 and 0 and u4 and 0. You cannot compute UTT because for each point we need the u at the previous line, and we have not previous line. Okay, and also we cannot compute UTT for all points at the first row. We cannot compute UTT 1 and 0, 2 and 0, 3 and 0, and 4 and 0. Okay, is it clear for you? Are you understand?
Yes.
Okay, very good. And for the next row, we can compute the UTT for all points. Please let me to raise this, some cases. We need some free space. Okay. For the next row, the t is 1. And for this row, the points are as follow: u 0 and 1. Okay, u 0 and 1. The next point, for the next point, we have u 1 and 1. For the next point, we have u 2 and 1, and then we have u 3 and 1, and for the next we have u4 and 1. If you be careful, you can see the second indexes for all points at this row is constant and is 1. And the last line, we have u 0 and 2, Then we have u1 and 2. For the next point, we have u2 and 2. Then u3 and 2. And finally, we have u4 and 2. Okay? I'm trying to compute uxx 0 and 1. I should use the information about u0 and 0 and also u0 and 2. The previous point is u0 and 0 by coefficient 1, u0 and 1 by coefficient -2, and finally u0 and 2 by coefficient 1. And we have u0 and 2 minus 2 u0 and 1 plus u0 and 0 over delta t2. And when we compute this fraction, the result is 2. For the next point, we are trying to utt 1 and 1. This line, utt 1 and 1. We should use u1 and 2 in the next line, in the next row, and also u1 and 0 in the previous line, and also u1 and 1 at the same line. So u1 and 2 minus 2 u1 and 1 plus u1 and 0 over delta t. And the result again is 2. For the other point at the second row, we should use similar way, and the result for all points is 2. And I'm trying to the second row, excuse me, the third row, means for T2. For T2, we have T2 equal to 1. For example, I try to use UTT at U0 and 3, 0 and 2. For the U0 and 2, we have not the next row, means we have not U0 and 3. And then we cannot compute UTT at 0 and 2 because we have not U0 and 3. The 3 means the fourth line, fourth row, and we have not fourth row. The next row, the last row for T is 2 because we have T0, T1, and T2, and we have not T3. And then U0 and 3 cannot compute. And also for UTT at 1 and 2, 2 and 2, 3 and 2, for all of them, we are right U1, U0 and 3, U1 and 3, U2 and 3, U3 and 3. And we have not the information for the U3. We have not U3, and this UTT don't compute by using symmetric finite difference for U respect T and T. Are you understand?
Yes, yes.
برای سطر اول و سطر آخر، یعنی برای T0 و T2 ما نمیتونیم مشتق مرتبه 2 رو برای نسبت به T حساب کنیم چون سطر قبل و سطر بعدی براشون وجود نداره. به این خاطر این مشتقات قابل محاسبه نیستن. Okay? This part is finished, and we are going to the next part, and at the next part we are trying to solve the PDE by using finite difference. not use the derivative. We are trying to compute u respect x, u respect t, u t by using finite difference, and at this time they are tools for solve the PDEs. منظورم به فارسی این میشه که ما تا الان تلاش کردیم مشتقات رو با فاینایت دیفرنس حل کنیم، حالا میخوایم بریم معادلات رو با فاینایت دیفرنس حل کنیم. اینا میشن یک تولز، میشن یک ابزار که ما از اینها استفاده کنیم برای حل معادلات. The goal of this course is solve the partial differential equation. هدف این درس حل عددی معادلات هستش، نه حالا اینکه فقط مشتقات رو حساب کنیم. Okay? It's the break time, and we can have 15 minutes for break, and then return to the class, come to the class and continue. Okay? وقت استراحت 15 دقیقه استراحت، بعد برمیگردیم درسمون رو ادامه میدیم. At this table, the formulas discussed are summarized in this table. The first row, we have the ux, or round of u over round of x. This is forward and the first order respect x, and the finite difference approximation is ui plus 1 n minus ui n over delta x. Everybody, ui n and n, you can write ui and n. Both of them are same. هر دو یکی هستن. Both of them are same. You can write u, I as a subscript and n as a superscript. And also you can write u, I and n. Both of them are correct. Okay? This is forward the finite difference approximation respect x. Because this derivative is respect x, the index of t is constant. The index of t is n, and we have for forward ui plus 1 and minus ui over delta x. The next row we have round u over round x, or u respect x. And the formula, the first difference approximation is backward, and the order of error is first in x, or first respect x, and the formula is ui and n minus ui minus 1 and n over delta x. The next row, we have the central finite difference for round u over round x, or u respect x, and the formula is ui plus 1 and n minus ui minus 1 and n over 2 delta x. 2 delta x is used for central finite difference. In forward and also backward finite difference, we have delta x. But in central finite difference, we have 2 delta x. The order of error in this formula is second. Forward and backward, the order of the error is first, but central, there the order of error, truncation error is second. For round 2u over round x2, or uxx, the symmetric finite difference approximation has this formula: ui plus 1 and n minus 2ui and n plus ui minus 1 and n over delta x2. This formula is used for uxx, not ux. The forward, backward, central is used for ux, and the symmetric is used for uxx. The order of error for the symmetric finite difference is second, and we have the order of truncation error is delta x2. And these formulas are also can be used for derivative respect t. For example, for round u over round t or ut, forward finite difference approximation is ui n plus 1 minus ui n. If you be careful, you can see for derivative of u respect x, the index for x means I is constant. I for in all of the formula, I is constant for respect derivative of u respect t. I is constant. Also, for the first part, you okay, let me come to the page. Excuse me. Here. For derivative of u respect x, n is constant, but for derivative of u respect t, I is constant. For backward finite difference, for the first derivative of u respect t, we have ui and n minus u and ui and n minus 1 over delta t. For central finite difference approximation, for u respect t, we have u I and n plus 1 minus u I and n minus 1 over 2 delta t, and the derivative and the order of error is O of delta t2. This formula is order of delta t2. And the last line, the last row is UTT or round 2u over round t2. And it's called symmetric finite difference. And this formula is uin plus 1 minus 2uin plus uin minus 1 over delta t2. This table is the summary of which of said until now. Okay, this is the summary of derivative respect of u respect xt, first derivative and also second derivative. Is it okay? This is the review. This table is the review for finite difference approximation. Okay? Are you here?
Okay.
Okay. From now on, our goal is to obtain a numerical solution for the PDEs using finite difference method. We are going to construct the scheme. The scheme means the method. A scheme means the method. Finite difference scheme means finite difference method. We are trying to construct finite difference x scheme to solve the partial differential equations or PDEs. The goal is solve the PDE, not solve the derivative, not obtain the derivative of u respect x. We are trying to solve PDE. In this page, you can see the simple PDE. This PDE is ut plus vux equal to 0. It is very simple PDE. Ut, the derivative of u is first. The derivative of u respect x is also first. This equation is called advection equation. 1D linear advection equation. 1D means one-dimensional linear advection equation. What is the solution of this PDE? منظور از جواب این معادله چی هستش بچه ها؟ What is the means of solution for this PDE? به چی میگیم جواب؟ What is the answer? What is the solution of this PDE? The solution of this PDE is a function such as u of x and t, such that u satisfied in this equation, in this PDE. The independent variable of this PDE is t for time and x for space. This is independent variables for this equation. The independent variables are this equation is t for time and x for space. The domain of x, or the computational domain for this problem is the interval from p to q. The interval from p to q is the domain for x, is the computational domain. It's called the computational domain. The computational domain is the domain for space, the domain for independent variable or x, that means space. The exact solution of this PDE is a function u equal to u of t and x. For this equation, we need the initial condition. What is the initial condition? Which of them can you say about initial condition? What is the initial condition? What is the initial condition? Which of them can discuss about the initial condition? Initial condition. You suppose t start from 0. T is bigger or equal to 0. Okay? T start from 0 and go ahead. Okay? The u at the first t means the u at t equal to 0 is an initial condition. Initial condition means the solution of u at a start of t, at the start point of t. In this example, the start point for t is 0, and then initial condition is the u at 0 and x. For all of x in the domain, in the computational domain, means for x from p to q. We put in u t equal to 0. T equal to 0 is the first point or the start point for t, and u 0 and x is the initial condition. At this problem, the initial condition is u0 and x equal to f of x. F of x is a known function, not unknown function. We have the fx. F of x, we have the f of x and is a known function, not unknown function. For example, f of x can be f of x equal to e power x, or f of x can be sine x or cosine of x, and so on. So means f of x is known function. I have a question from you. The domain of this problem is infinite number of point or consists of finite point. سوالم اینه دامنه این مسئله شامل تعداد مشخصی نقطه هست یا بی نهایت نقطه داره. The domain of this problem has the infinite point or the finite point. What's your solution? What's your opinion? For the exact solution, not approximate solution.
تقول المجال الدالة نقاط بنهاية، يعني كم نقاطها كلها نقاط محددة.
محددة هنا.
Exact solution.
اي بس احتمال يقول لك بين البي والكيو كم نقاط اكو.
اي بس مهما كانت هي محددة.
يعني فاينايت.
اي فاينايت. اي
فاينايت. هم بقى فاينايت.
Infinite. No, infinite. Exact solution, not discretization. We don't discrete this problem. Until now, we don't discrete this problem. We have not grid. We have a domain. Domain is for x start p to q. All of point from p to q. Okay? All of point from p to q. It consists of infinite point, okay? Not finite point. We are not x0, x1, x2, x3 until now. We have not xi or tj. All of the points from p to q is important. And also for t start from 0, okay? Start from 0 and go ahead. Because of this, the computational domain has infinite number of points. And when we talk about exact solution, this means the u of au of t and x, that the infinite number of value of the independent variable t and x of the domain satisfy the PDE and also the initial condition. The exact solution, not approximate solution. When we discrete the domain, we have the approximate solution, not exact solution. Okay? When we use x0, x1, x2, x3 and all and so and so, we have approximate solution, not exact solution. Exact solution means the u of t and x that satisfy in PDE and also the initial condition for all point in the domain, means all point from P to A to Q for computational domain and for all value of T. This is the exact solution. Okay? But we are not looking for the exact solution at this course. At this now, we are not looking for the exact solution to PDEs. We are going to look for approximate or numerical solution for PDE. خانم زینب من این قسمت رو میگم، حالا اگر بچه‌ها خوب انگلیسی متوجه نشدن شما لطفاً به عربی براشون بگید. ببینید ما وقتی از جواب exact صحبت میکنیم میگیم exact solution، منظور ما جواب واقعی هست که هم در PDE مون صدق میکنه و هم در شرط اولیه برای همه نقاط دامنه، یعنی برای همه نقاطی که از P هستن تا Q و به ازای همه T ها. درسته؟ پس exact solution جواب دقیق یعنی جوابی که در PDE و همینطور در شرط اولیه ما صدق میکنه به ازای همه نقاط، به ازای اون بی نهایت نقطه که x هاشون از P تا Q هست و T هاشون هم که بزرگتر از 0 میشه. این منظور جواب چی؟ جواب دقیق هست. اگر براتون واضح هست اعلام بفرمایید و اگر براتون واضح هست همین مفهوم رو برای بچه‌ها لطفاً توضیح بدید.
بله هم بقیه
براتون واضح هست؟
بله متوجه شدم.
لطفاً برای بچه‌ها توضیح بدید. ممنونم.
تقول عندنا بما أن عندنا مجال الدالة وإحنا النقاط اللي أخذناها بالنسبة ذنيك PDE تقول عليهن، يعني ذنيك مال النقاط ذنيك مال مشتقة الأولى والثانية، تقول راح تكون عندنا ما لا نهاية من النقاط للمجال الدالة اللي بين ال P وال Q. أوكي؟
Okay everybody. حالا اینم براشون بگیم حالا ما توی این درس دنبال جواب دقیق نیستیم. بحث ما حل عددی هست، حل تقریبی هست. ما به دنبال این هستیم که برای این معادلات جواب تقریبی به دست بیاریم. پس هدف ما توی این درس حل تحلیلی یا آنالیتیکال سولوشن نیست. هدف نومریکال سولوشن یا اپروکسیمیت سولوشنه. میخوایم اینها رو بیایم مشتقاتشو با فرمول‌های تقریبی جایگذاری کنیم، شبکه هم به دست بیاریم، جواب رو تقریب بزنیم. دنبال حل واقعی نیستیم تو این درس. ممنون میشم به شما منتقل کنیم.
تقول موضوعنا اليوم هذا الموضوع مال الدرس اليوم، تقول احنا ما راح ناخذ بالضبط ايش قد، ان مثلا اذا نريد نشتق مثلا نطلع قيمة x نطلع مشتقة بالنسبة للx والt، تقول ما راح نقدر نطلع قيمة الضبط مالته يعني اللي يساوي، راح ناخذ التقريب بالنسبة إلهن لأن موضوعنا مو exactly. Okay?
Everybody, are you understand? Do you understand? Okay. We are going to use approximate solution. The first step is spatial discretization. Okay, we are going to discretize the spatial domain, means discretization from P to Q. Okay, this is familiar for you because in this example I'm work for you the discretization. You have seen the discretization for x and T. This is here. Start from the first point and by the step size delta x, we continue and we have x1, x2, x3, x4 until we arrive to the end point. Does the spatial discretization, you should the computational domain individuate to the finite point and finite subinterval. We should divide the interval P to Q to finite point and finite interval. For example, we want to put endpoint to interval P to Q. For this case, delta x equal to q minus 1 over n minus 1. For example, you put p is equal 0 and q equal to 2. And we want to put 10 point in the interval from 0 to 2. This means n equal to 10. Okay? What is the delta x? What is the step size for computational domain? When we want to have n point in computational domain, we can compute delta x by q minus p over n minus 1. And this example, q is 2 and p is 0. Okay? And n is 10. And for example, delta x is 2 minus 0 over 9. For simplicity, we get n equal 11. Please let me to correct for simplicity. If we put n equal to 11, delta x or step size for computational domain is q minus p. Q is 2 and p is 0. Q minus p is 2 over n minus 1 is 10. 2 over 10 is 0.2. Okay? And we can compute delta x. At now, by using this delta x, you can construct the grid. You can construct the mesh. Mesh means the set of finite point. When we replace the computational domain by using finite point, it is called the mesh or is called the grid. We start from the start point. A start point in general is P. In general, a start point is called P. X1 equal P. Everybody, you can write the start point x0, or you can put x1. It is optional. It is not important. You can start x0 or x1. It is optional. خانم زینب این که شما نقطه شروع x0 بگیرید یا x1 بگیرید دلخواهه. میتونید هم با x0 شروع کنید هم با x1 شروع کنید. It's optional. اگر عادت کنید با x1 شروع کنید برای کدنویسی با مطلب راحت تر هستید. چون مطلب اصلا اندازه صفر رو نمیشناسه. اگر سعی کنید با x1 شروع کنید کدنویسیاتون راحت تر میشه. اوکی؟
إذا تبدون بالنسبة للإكسات، إذا تبدون من الواحد أحسن لكم، حتى إذا تريدون تطبعون برنامج اسمه ماتلاب فيطلع لكم بالواحد أرتب، وهناك ما يبدي من الصفر. فمن وجاء إذا بتبدين بالإكس يعني تبدي من الإكس الصفر، إكس ابدي بالواحد.
It is better that you use x1 for the start point, not x0, but not important. It is better. It's optional, and it's better you use x1 for the start point, for the p. X1 equal to p, x2 is p plus delta x, xi equal p plus I minus 1 delta x, or you can write xi equal to xi minus 1 plus delta x. This means if you plus delta x to each point, you can find the next point. Each point you can plus delta x, you can find the next point. Xi equal to xi minus 1 plus delta x, or xi plus 1 equal xi plus delta x. And the finite point for the computational domain is here. The first point is x1, the next point x2, the next point x3, and finally the end point is q, xn equal to q, or the end point. This is discretized computational domain, discretized of extended computational domain. It is familiar for you because I solve a problem by discretization of x and also by t. For solve this PDE, as you can see, we have ut plus v ux equal v ux equal to 0. This is a advection PDE. Okay. For solving approximately, we replace ux at tn and xi by forward finite difference approximation. You replace ux by forward approximation at xi and tn is ui plus 1 and n minus ui and n over delta x. We replace ux by this approximated formula. Okay. When we replace this approximate formula for u respect x, we have ut plus v. This forward approximation for u respect x. Then we have ut plus v, ui plus 1 and n minus ui and n over delta x equal to 0. This is semi-discrete formula. Semi-discrete formula. Why? Because we only discrete the spatial variable. We discrete the x, not t, and the t is constant. Okay, this is semi-discretization formula. This is method of line. This is called method of line. But when we replace ut by using the approximation finite difference approximation, such as forward, backward, or central, we have the discretization form of PDE. Until now, we have semi-discretization formulation for this PDE. For time discretization, we have ut is approximate by ui n plus 1 minus ui and n over delta t. It is forward or backward finite difference for u respect t. It is forward or backward? Okay, it is the forward approximation finite difference for u respect t, because the index of same point is I and n. It is here. We are at xi and tn, and the index is used are from the next point uin plus 1 minus ui and 1 and n over delta t. By Replacing this u respect t in the PDE, we have ui and n plus 1 minus ui and n over delta t plus v ui plus 1 and n minus ui and n over delta x. I have a question from you. At this discretization form of the PDE, what times is used? How many times is used? How many rows is used? 1 or 1 or 2 or 3? How many times? What which index indicate the times? Which index indicate the time? کدوم اندیس بیانگر زمانه؟ I or n? Which index indicate the time? Everybody, are you here? Which index?
Yes.
I is used for x, okay? I for
Yes.
is used for x, okay? And n
Yes.
is used for t, okay? In this formula, we have n and n plus 1. We have 2 times, 2 rows, okay? This means
لا ده تسأل تقول لك يا هي اللي يدل على التي يا هو اللي يدل على الاكس.
This formula is based on Tn and Tn plus 1, okay? This in this formula we have n and n plus 1. If we have the information at Tn, we can obtain the value of u at Tn plus 1. خانم زینب نگاه کنید، اینو میخوام بهشون بگم. ما تو این فرمول هم n داریم هم n به اضافه 1. خب اگر ما اطلاعات رو در زمان Tn داشته باشیم، میتونیم از این اطلاعات استفاده کنیم و مقادیر u رو در گام بعدی زمانی در زمان بعد به دست بیاریم. برای خودتون واضحه الان چی میخوام بگم؟ نگاه کنید، ما توی این فرمول هم زمان n داریم هم زمان n به اضافه 1 داریم. حالا ما میخوایم از اطلاعات زمان Tn استفاده کنیم و مقادیر u رو در گام زمانی بعدی به دست بیاریم. این کاری است که میخوایم توی مثال انجام بدیم.
تقول بهذا القانون اللي عقبالكم هي 2 17. اوكي، تقول عندنا وقتين، الوقت الاول اللي يو للأس ان، والوقت الثاني الاي هي بالنسبة للاكس هي مؤشرة النيجاتيف، الاي هو اكس، يبقى التي شنو هو اللي يصير فوق الان؟ عندنا ان وعندنا ان زائد 1. اوكي، تقول انا التي اليو للأس ان اللي هي تي للان اول وقت انا اقدر احصل عليه، من عليه اضيف له 1 احصل عليه من على الزمن الثاني.
Okay, everybody, I repeat, if we have the information at Tn, we can compute, we can obtain the information at Tn plus 1. At this formula, when we obtain u, I and n plus 1 from the last formula, we have ui n plus 1 is equal to uin minus v delta t over delta x ui plus 1 and n minus ui and n. Is it okay? From 2.17 we can obtain the ui and n plus 1 and we can receive 2.17b. Okay, we solve this equation. Respect ui and n plus 1 and we obtain ui and n plus 1. We have 217b. Is it okay? از فرمول 2.10a اگر ما ui پلاس n به اضافه 1 رو حساب کنیم فرمول 2.17b به دست میاد. Okay? Is it clear for all of you? Do you want I solve this from 2.17a to 2.17b? Okay, I solve this. First, I stay ui n plus 1 minus ui and n over delta x. And I move this term from left to right. I move this term from left to right. And we have minus v u I plus 1 and n minus u I and n over delta x. Okay? And then multiply both of sides at delta x. Both of sides multiply in delta t. Okay? After multiply delta t, we have ui n plus 1 minus ui and n, and this term equal to minus 1 delta t over delta x, and then we have ui plus 1 and n minus ui and n. Okay? And finally, we move minus ui and n from left to right. When we move minus ui and n from left to right, we have 2.117b. We have this formula ui and n plus 1 equal to ui and n minus v delta t over delta x ui plus 1 and n minus ui and n. Is it okay? Are you on?
Okay. Yes.
Great. Let me clear this page. The last formula help us to compute u at the time level n plus 1 by using time level n. The right side of this formula is at Tn. But the left side is based on n plus 1. Please be careful. In the right hand side, we have n, again n, and again n. درسته؟ All of u at the right side is at t equal to tn. And the left hand side is base n plus 1. This is the scheme for solving this PDE. By using this scheme, we can compute this PDE. We can solve this PDE by approximately. This scheme is called time marching space scheme. This formula, this method is called time marching scheme. Okay, this formula that we use the forward approximation for u respect t and for u respect x is called time marching scheme. And we can use the value of u at the time level tn plus 1 by using the information at time level t equal to tn.
فقط n چیه؟
n زمانه. همون j که اونجا استفاده می‌کردی اینجا میگه n. این همون jه.
نه t n.
n همون j. مثلا میگیم t0 t1 t اونجا در مثالی که حل کردم میگفتم چی؟ میگفتم t1. اوکی؟ t1.
پس الان u i به توان n زائد n بر 1.
به تو گفتم دیگه. ببینید من میتونم بنویسم u i n رو بالا بنویسم یا میتونم بنویسم u i and n. جفتش یکی هستم. مثلا من خودم عادت دارم اندیس پایین مینویسم. راحت تره. شما میتونید نه مثلا چی بنویسید. مثلا من عادت کردم اندیس پایین مینویسم تو محاسباتم. اکثر کتابا مثلا اندیس پایین مینویسن، بعضی کتابا نه. مثلا اندیس x رو پایین مینویسن، اندیس زمان رو بالا مینویسن. جفتش درسته، هیچ فرقی نمیکنه. جلسه قبلم گفتم بهتون، ابتدای بحثم بهتون گفتم میشه هر دوشو پایین نوشت، میشه مکان پایین زمان بالا بنویسیم. این به بچه‌ها اگه ابهامی هست برطرف بشه براشون.
عرفتوا السؤال الآن عن سألتنا شنو هو هذا الان اللي موجود هنا فوق اليو؟ يعني المشتقة عدد الرتب المشتقات. قالت لا هو الجي نفس الان. مو كان عندنا اي وجي. هسه أنا مرة بعض الأوقات بكتب يكتبوا لي فوق، بعض الأوقات يكتبون بصف الان. وصلت الفكرة؟
Did you understand? Okay. بس
يعني زينب هاي الان مو اس.
لا مو اس، نفسها الجي اللي بصف الاي كنا ناخذهن.
انا توقعت اس. توقعت اس حسبالي يعني نفس
اي لا مو اس.
يلا مشكورة
Please attention here, everybody. Here we have u, I, and n equal to u at tn and xi. I is the index for x and n is the index for t. Until now, we use j. At this time, n means j. You can use n or j or k. It is optional. It is دلخواه. شما میتونید هر چی خواستین استفاده کنید. بعضی کتابا I میذارن، بعضیا n میذارن، بعضیا k میذارن، بعضیا j میذارن. It is optional. You can use xi and tj or xi and tk or you can use xj and ti. It is optional and you can use every index that you like. Okay?
اوكي. خان باقری میگن این مربع که نوشتن تایم مارچینگ. میگن این چیه؟
اسم این فرموله هست. اسم این 218 بهش میگن
اسم هذا القانون ال 218. هو نفسه هو اسم العالم هذا ايش بيك؟
اسم این فرمولی که به دست آوردیم بهش میگن تایم مارچینگ. اوکی؟ حالا at this time this is a question. How do use this 2.18 and compute the value of u at the mesh grid? For this session, it's enough, and for the next session, I try to explain this formulation and solve this problem. خانم زینب نگاه کنید، اگه من از روی کتاب بخوام به شما بگم به این مطالب رو، حالا به نظرم میرسه که یک مقدار کتاب‌ها حالا ممکنه باز نکرده باشه مطلب رو. من تلاش میکنم برای هفته دیگه این رو به شکل دست‌نویس، مثل مثالی که براتون حل کردم از کتاب بود، من تلاش میکنم که اینا رو براتون حل کنم، به دست‌نویس مراحل حل براتون بنویسم که بهتر بحث رو یاد بگیریم.
اوکی ان شاء الله.
الان متوجه منظورم شد؟ یا کتاب باید یعنی نه این کتاب، من این کتابی که برای شما انتخاب کردم این ساده‌ترین کتاب هستش تو پی دی ها، یعنی ما از این ساده‌تر کتاب وجود نداره برای حل پی دی. ولی باز هم اگر دقت کنید مثلا ممکنه اونجوری که باید مطالب باز نکرده باشه. من چون دوست دارم شما بحث رو یاد بگیریم، حالا یک تایم تو این هفته در نظر بگیرم، خودم بچینم برای شما دستی اینا رو حل کنم و بعد براتون میفرستم بهتر متوجه بشین. بخاطر من که براتون حل کنم اونا رو به شکل دست‌نویس با توضیحات بیشتر که بحث رو بهتر متوجه بشین.
تقول أنا هذا الكتاب اللي اختارته لكم بالنسبة معادلات تفاضلية، هذا أسهل كتاب اختارت لكم إياه، وراح أدز لكم إذا مو عندنا هذا شنو عندنا ملاحظات وراء هذا القانون، راح أعطيكم أمثلة عليهن حتى أحلهن، أدز لكم إياهن أحلهن وأدز لكم على الأسبوع الجاي حتى تفتهموهن شلون. نحن حتى ما أعطيكم بس الملاحظات وقبل.
I try to write more details. I try to write more details of the solution of this problem by handwriting. And the next session, I explain the method for solve this formulation. The next session, we want to use 2.18 to solve the PDE. The original PDE is UT plus V UX equal to 0, okay? And this formulation is the time marching scheme for approximate the original PDE. This is the approximate scheme or approximate method for solve the UT plus VUX equal to 0. It is approximate formula. It is the original or original PDE. Okay. From this 2.80, we can use the information at the previous time to compute the information at the next time. For example, you suppose we are at T0, okay? And T0 is 0. we are at t0. And for x, we have x0 and then x1 and then we have x2 and for example finally we have x3. Okay, and u at all of these points is known. It is initial condition. Based on initial condition, we have u at t0. Is it clear? Based on initial condition means the value of u at t0. Please be careful and see this part. This is initial condition. Okay, based on initial condition, we have the u at t0. At t0, that equal to 0, we have the exact solution of u. At t0, for example, it x1, x2, x3, and all of them, we have the exact solution, because for x1, the value of u is f of x1. The next point, the value of u is f of x2. Okay? The next point, we have f of x3. This means the value of u at t0, it is not unknown, it is known. Is it clear? Have you understand? خانم زینب اینو میخوام بگم در زمان t مساوی با 0 یو مجهول نیست. تو بقیه زمان‌ها یو مجهوله. در زمان اول بنابر شرط اولیه‌ای که ما داریم یو مجهول نیست. یو چی میشه مقادیرش؟ همون f میشه که گفتیم n معلوم هست. این f معلوم مجهول نیست. یعنی ما شرط اولیه بهمون مقادیر یو رو در زمان اولیه که همون t0 هست بهمون میده. درسته؟ حالا ما دیگه در بقیه زمانها t رو نداریم و میخوایم به کمک این t که همون f هست در زمان اولیه در بقیه زمانها u رو حساب کنیم. Everybody, please attention to me.
Okay.
We have the value of u. We have the value of u at t0. At time t0, we have the value of u. از کجا؟ From the initial condition. From initial condition, we have the value of u at t0. Okay? And unknown, at the value of u is known, but no unknown. It is known based on initial condition. And for t1 and t2 and the other time, we have not the value of u. And the other time, we have not the value of u. And by using the time marching scheme, we can compute the value of u at the next time. خانم زینب خودتون متوجه شدید من چی گفتم؟
من متوجه بودم، بذار بگم.
خیلی هم
ممنون. تقول أول قانون اللي راح أبدي به بالبداية في صفحة 24. هذا قانون الرئيسي اللي هو يو للصفر وإكس يساوي f of الإكس. يقول إذا كان الزمن صفر التي نوت يساوي صفر راح يكون عندنا الدالة f of الإكس، بس المنو والمتغيرات متغيرات الإكس 1 وإكس 2 إلى ما لا نهاية من الإكسات. أوكي، هذا القانون استخدمه فقط في حال إيش وقت إذا عندي t النوت يساوي صفر. إذا كان الزمن اللي هي t نوت مو صفر استخدم هذا قانون 218 اللي هي قانون تايم مارشنج. اوكي اتوقع وصلت الفكرة.
Have you understand?
اوكي.
Okay, it is sufficient for this session, and we will continue at the next session. If you have any question, please ask.
No thank you.
خانم زینب بهشون بگید اگه تلاششون رو بیشتر کنن، من بیشتر میرسم مطالبی که دوست دارم بهتون بگم. اگر کمتر درس رو بخونن دچار مشکل میشیم. الان من خیلی سرعتم کنده، چون یک مطلب رو چندین بار مثلا باید بگم، ولی اگه بچه‌ها خودشون مسئله حل کنن مثلا کتاب بخونن با کلاس پیش بیان، خیلی سرعتمون بالاتر پیش میره، خیلی مطالب بهتر میتونم بهتون بگم، میدونم براتون لازم میشه.
بله.
مثلا مطالب تا اینجایی که گفتم از رو کتاب و جزوه هر چی گفتم مثلا باید خونده باشین. الان شما باید این فایل کتاب رو تا همین صفحه که الان بهتون گفتم تا صفحه 627 باید بلد باشین. یعنی من هفته دیگه تا صفحه 27 میپرسم ازتون، باید بلد باشین. کتاب تا صفحه 27 باید بلد باشین. یه سری اگزمپل براتون گفتم، اینا هم که باید حدود 6-7 قسمت بود. این هم باید در واقع اینا 5 قسمت بود. این هم باید بلد باشین. یه سری هم اکسرسایز براتون فرستادم که خودم حلش کردم، حلش هم براتون فرستادم. حل این باید بلد باشین. یعنی من از شما انتظار دارم هفته دیگه هم که سر کلاس میاد ان شاءالله هم این بلد باشین، همین اگزمپل ها رو خوب خونده باشین، بلد باشین، هم کتاب تا صفحه 27. از اون هفته کویز میگیرم. بهشون بگین هفته دیگه از بچه‌ها کویز میگیره، یک امتحان کوچیک ازتون میگیرم.
بله.
لطفاً
تقول الأسبوع الجاي من صفحة 1 ل27 اللي هسه آخر شيء شرحناه، لازم تقروهن المادة من غير الأمثلة اللي نطيناه ولا تسكت. الأمثلة والأمثلة اللي هي حلت لنا إياهن بخطأ إيدها، وأكو بعد أمثلة ثانية دزت لنا إياهن هسه إحنا حليناهن بالمحاضرة. تقول راح أمتحنكم الأسبوع الجاي امتحان يومي. تقول إذا ما تمشون وياي فنتأخر، أكو معلومات لازم أطفكم إياها عن تحتاجوهن بكورس الثالث.
Okay, please increase your activity. Please increase your activity and study and review the book and the handbook that I sent to you. Okay?
Okay.
Goodbye. And if you don't
Okay.
have any question, we can goodbye to each other. Goodbye. Have a nice time.
Goodbye.
Have a nice time.
Goodbye.